A very good morning. Today I am going to discuss about ring counters. So in the previous session we had a clear informations about decade counters. So in this session we are going to discuss about ring counter, right? So a ring counter is a typical application of shift registers. A ring counter is almost the same as the shift register. So here the only change is that the output of the last flip flop is connected to the input of the first flip flop in the case of the ring counter, but in the case of the shift register, it is taken as output. Except for this, all the other rings are the same. So the number of states in ring counter is equal to number of flip-flops used here. So this is all about ring counter. The very important note is the number of states in ring counter should be always equal to number of flip-flops used in this circuit diagram. Okay. So how many states are there? You have to calculate accordingly. You have to use the flip-flops. If 10 states are there, you have to use 10 flip-flop. If 5 states are here, we have to use 5 flip-flops. So your number of flip-flops depends on number of states in the ring counter. So this is the circuit diagram of a ring counter. You can see here. We have designed a 4-bit ring counter. So we have 4 flip-flops here. I have taken D flip-flop for your easy understanding, because your D flip-flop, whatever you give in the inputs will be directly received, the same input will be directly received in the output. So it is easy for you to understand by implementing ring counter using D flip-flop. So I have given a clock, it is a common clock, and also you have a clear reset pin. So if you give clear reset, all the previous data will be cleared and you can start from the first. So 4 flip-flops, flip-flop 0, flip-flop 1, flip-flop 2 and flip-flop 3. And next you can see these flip-flops are connected to one another, like flip-flop 0 outputs are connected to flip-flop 1. So the clock is common here. You can see the clock is common to all the flip-flops from first to last. And clear reset pin is also common, right? So the only thing you have to note here is the output of one flip-flop is given as the input to the another flip-flop. So you can see here the output of flip-flop 0 Q0 is given as the input to the second flip-flop D1, right? So the output of second flip-flop Q1 is given as the input to the third flip-flop D2. So the output of Q2 of the third flip-flop is given as an input to the fourth flip-flop D3. Then finally what we have to focus here is the output of Q3 is taken and given as an input to the first flip-flop again. So this is a ring type. So the output should be given to the input again, first flip-flop to second flip-flop to third flip-flop, then third flip-flop to fourth flip-flop. Then your output again will be given to your first flip-flop. So these ring type is said to be as ring counters. Okay. So it is a ring type, like again and again the output will again come to input, then from the first flip-flop to the next flip-flop, then from second flip-flop to third flip-flop. Likewise it will be it is almost same like what to say, it is a shift register. It has the same operation like our shift register. We can see that the clock pulse is applied to all the flip-flops simultaneously. So it is said to be a synchronous counter. We know very well the difference between synchronous and asynchronous. If it is a common clock pulse, it is said to be a synchronous. Also here we use overriding input, which is said to be as ORI for each flip-flop. Preset PR and clear are used as ORI. When PR is 0, then the output is 1, and when clear is 0, then the output is 0. Both PR and clear are active low signal that always works in value 0. PR is equal to Q is equal to 1, clear is equal to 0, whereas Q is equal to 0. Right? This is the working principle of flip-flop. You can see here. If preset is 1, then it is low. If ORI is low, then this will be your output. It has a diagonal output. So you can see here. It has a diagonal output. So you can see here. Yes. Then the presetted one is generated by making ORI low, and the time clock becomes don't care. So in this way we can design a 4-bit ring counter using 4D flip-flops. There are two types of ring counters, straight ring counter and twisted ring counter. So this is the block diagram of straight ring counter. You can see it is in straight, and twisted ring counter, you can see there is a difference from output to input. So this is all about straight ring counter and twisted ring counter. Thank you all.